Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about three-dimensional problems using our good friend Pythagoras. So let's get to it, shall we? Okay, so three-dimensional problems. Let's take a look at our first one. A 50 meter, this is pretty straightforward. A 50 meter rope is attached inside an empty cylindrical wheat silo of diameter 12 meters, as shown. I did not show it because we need to be able to draw these things. How high is the wheat silo? Okay, so we got to draw a cylinder, and you need to get used to being able to draw nice pictures. Okay, and maybe you put a dotted line for the part you can't see. And I'll go another color, maybe green. And let's say we have a rope from there to there inside of the cylinder. And they tell me that it is 50 meters. And the diameter of the wheat silo is 12. So there we go, we have a drawing. Well, if it's a rope and it's inside and it is a regular cylinder, which we can assume what we have is a right triangle, and I will redraw it. Just bring it out. Sometimes that helps too. Right triangle, 12, 50. They want the height of the wheat silo, so I'll call that x. Pythagorean theorem, x squared plus 12 squared equals 50 squared. Let's see, x squared is going to equal 2356. After we do a little bit of arithmetic, x equals root 2356, and I know I've said I'd like exact answers, but in this case, it's a real world application. It's not just the height of a cylinder, it's a wheat silo. So common sense says we should go ahead and use our calculator and say that it's about 48.5, and our units are meters. So it's about a height of 48.5 meters. All right, next one. The floor of a room is 6 meters by 4 meters and its height is 3 meters. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. So we have to make an assumption here. We have to assume that the room is a rectangular, perfectly rectangular. So you can do that. If they don't tell you and it's obvious, you can go ahead and do that. So to draw it, if you're not good at it, I'm just going to start with a rectangle out front. That's going to be my side. Then a line going out this way to be the front, another line parallel to it, and I'll draw it here. Hopefully you see where I'm going. Draw this down. And so I've got a decent rectangular prism. Okay, and then I'll try and estimate like the dotted lines back here to see the insides of the rectangular prism. In this case, it's a room. Okay, so I know that this is 6 meters. I'll let that be 6. I'll let this be the 4, and I know that the height of the room is 3. So this is 3, this is 3, this is 3, and this is 3. And then we need to find the distance from a corner point on the floor to the opposite corner point on the ceiling. So let me change colors. I'll go blue here. And actually, let's do a line so it can be a bit more accurate. Okay, so let's do this. And so I'm looking for that distance, if you can see that. And let me go ahead and make it dash. Maybe that'll make it a little clearer. Boom. Okay. So we're looking for that distance. Okay. Well, can't we also draw this right here and form ourselves a right triangle? Again, I'll make it dash because theoretically it's inside of the room. Whoops, there we go. Okay, so we've made it dashed. And what we have is a right triangle. Okay, well, what do I know about that right triangle? I'm going to redraw it out here in green. So the triangle I'm drawing, just to be clear, is this one. You see it? Okay, let me get rid of that nastiness. And there we go. What a terrible line there. Sorry about that. And the only thing I know is that this is 3, and this is what I'm looking for. I'm going to call it D. That's this thing right here. I'll label it D right here. And if I could find this out, then I would have this length right here. So I'm going to call that X. Well, now I want you to look at the bottom here. This triangle, boom, 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 okay, on the floor of the room, okay? Well, the floor, this is going to be a right angle. And let me just redraw that triangle for us. Boom, boom, boom. And it's on the floor. And what am I talking about? Well, this side here is this. It's 4. This side here is the front edge. This is X. I'm sorry, 6. And then this is X, our hypotenuse. Now this X is this same X right here. It's 2 triangles sharing this side. This triangle here, and then the triangle on the floor. So here I can say x squared is equal to 4 squared plus 6 squared, which is 16 plus 36. So x, 36 plus 16, which is going to be 52. So then x is equal to root 52, and let's leave it that way. Do not use your calculator to simplify that, because we want to be as exact as possible when we replace it up here. And now we're in business. D squared is equal to 3 squared plus root 52 squared. So D squared is equal to 9 plus 52. D squared is equal to 61. So the distance is equal to root 61, which is approximately equal to 7.81, and our units are meters. Again, I did this because we got a real life application. 7.81 meters. And I got one more for you. A pyramid, of height 40 meters has a square base with edges of 50 meters. Determine the length of the slant edges. Holy smokes. All right, so square pyramid. So I'm first going to draw the front bottom edge of the pyramid, and then I'll draw this one. I'll bring it out this way, the right side of it, and then this would be dashed, and this would be dashed. And I always draw like an imaginary point up here, which is the vertex of the pyramid, so I have something to aim at to draw the other edges. And then we would have a dashed one back here. Okay. So I'm going to draw the center here, and let me go with a different color. I'll go with blue. It has a height of 40 centimeters. So if I drop a perpendicular down here, boom, I know that that height right there is 40, and it has bases of 50. And we have to find this slant height right here, not slant height, yeah, the slant edges, which is this one right here. I'm going to call that S. And if I draw a line right there, I've got myself a right triangle. So I'm going to go ahead and draw that, because that's going to be the triangle that we're going to use. And I have called this slant edge S, and I know that this is 40 right here. This is 40, this is my S, and now I need this length right here. So I'm going to call this X right there. And I'm going to draw an auxiliary line that way. And while the picture is not perfect, if I continued this line here And then this other line in the back, I would be drawing diagonals of a square, which I know meet at a right angle. They're perpendicular. The diagonals of a square are perpendicular. So and they bisect one another. So they're all equal. So this is equal to this, is equal to this, is equal to this. So if this is x, this is also x. So I'm going to pull that triangle out of there and do it upright. And do it upright. So kaboom. Again, x, x. Those are these two sides. And this edge corresponds with this edge. So that's 50. And remember, this x is the same as as this x right here. See how that comes down? It's not the same as s. It's this x. They're the same x's. So I can say that x squared plus x squared is equal to 50. 2x squared is equal to 50. X squared is equal to 25. So that means x is equal to 5. Substitute that in right there, and all of a sudden we are in business, kids. S squared equals 40 squared plus 5 squared. S squared equals 1600 plus 25. So S squared is going to equal 1625. S equals square root 1625, which of course we know is approximately equal to 53.4. So that would be 53.4 meters are the units. All right, that is all I got. Hope you like it. I know I did. So let's get back to it. Or no. With that, I am out.